This Zoom session is being brought to you by the Fractal Inverse Bullseye S Swirl. Yeah. All right. Okay, today we go on to the law of cosines. This helps us solve all the triangles we couldn't solve by the law of sines. Uh, okay, and the law of cosines, we could solve angle side angle problems and angle angle side problems and side side angle problems. This will help us solve side angle side problems, side problems, and also could be used for side side angle. Okay, here we go. Starting with a triangle, we have an angle side angle problem, or side angle side problem, my apologies. Here's a side A, here's the angle gamma, and here's the side B. And the question is, what is the opposite side C? So you can think of this as a pair of tongs, and the angle between the two lengths, between the two tongs, can change as can the length of the tongs and how far between the two endpoints. Okay, well, and we arrange this triangle with on the coordinate plane so that this point here is at b by 0, this point here is at 0 by 0, and this point here, out of distance a at an angle gamma is therefore at a cos gamma by a sine gamma. And the question is, what is this distance c? Well, we have a distance between 2 points, so we use the distance formula. C squared equals this minus this, a cos gamma minus b squared, plus this minus this, a sine gamma minus 0 squared. So here's the equation. And now we're going to expand it and simplify and so on. Okay, first we expand the square of a difference, a squared cos squared gamma minus 2ab cos gamma plus b squared. This minus 0 just goes away, and so we could get a squared sine squared gamma. Okay, now these two, a squared cos squared gamma and a squared sine squared gamma, we put together as a squared times cos squared plus sine gamma plus sine squared gamma. Then there's a b squared term, and then there's a minus 2ab cos gamma. Now, cos squared gamma plus sine squared gamma is always 1. So this just becomes c squared equals a squared plus b squared minus 2ab cosine gamma. This is part of the law of cosines. Which we can take a square root, it's this. C equals root of a squared plus b squared minus 2ab cos gamma. Now, if we swap around the labels, we'll get two other identities. Change a to b to c to a, alpha to beta to gamma to alpha. If you do that, you get a equals root of b squared plus c squared minus 2bc cos alpha. B equals root of c squared plus a squared minus 2ca cos beta. The general rule is that a side equals the square root of the sum of squares of the other two sides minus twice their product times cosine of the angle opposite the side. And this solves side angle side problems. Given two sides and the angle between them, we get the third side. Now, if we're starting from here, a squared equals b squared plus c squared minus 2bc cos gamma, and we solve for cosine alpha, well, okay, we transpose this to the left, that to the right, divide by 2bc, and take an arc cosine, and you get alpha equals arc cosine of the quantity b squared plus c squared minus a squared over 2bc. Now, if we swap around the labels, alpha to beta to gamma, a to b to c to a, then we also get, therefore, that beta is arc cosine of c squared plus b squared minus c squared over 2ca, and gamma is arc cosine of a squared plus b squared minus c squared over 2ab. I call this the law of arc cosines. I mean, you can just say that it's derived from the law of cosines. They don't call it that in the book, but I think it's useful. In fact, it's very useful. Given three sides, A, B, and C, we can, from this formula, get the three angles, A, side, 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 A. Although generally it's a little bit less work to use to solve for alpha and beta and then find gamma by 180 minus the other two. So for example, here we have triangle with sides A is 6, B is 5, C is 8. What's alpha? What's beta? What's gamma? Well, so the rules goes as follows. Alpha is arc cosine of b squared plus c squared, those are the two sides next to it, minus a squared over the side, that's the side opposite, over 2bc. All right, so just plug in the numbers. 5 squared plus 8 squared minus 6 squared over 2 times 5 times 8 Arc cosine of that after a few keystrokes on your calculator gets you about 48.5 degrees. Now I can do similarly with beta. Arc cosine of c squared plus a squared minus b squared over 2ca. Plug in the numbers, out comes 38.6 degrees. Gamma, we can, okay, we'll do it by law of arc cosines. Arc cosine of a squared plus b squared minus c squared over 2ab. It gets that, and that's 92.9 degrees. Although, if you have these two angles, then you subtract them from 180, and you should get the exact same thing, 92.9 degrees. Here we have a bearing problem. An airplane goes 150 miles due north, and it goes 100 miles, 50 degrees east of north. How far does it travel, and at what angle? What's the distance? What's the angle? This is known as the bearing. How far something goes is tilted, how many degrees clockwise of north it goes. All right, so now this D, well, okay, if this is 50 degrees, then this is 130 degrees. And now we have a side angle side problem. 150 miles here, 130 degrees here, 100 miles here. So this D is 150 squared plus 100 squared minus twice 150 times 100 cosine of 130, like that. And that'll get you approximately 227.6 miles. Now, to find this angle theta, we have these two sides, and then we all have this third side, 227.6. And so law of arc cosines will be arc cosine of the adjacent side squared, 150 squared plus 227.6 squared minus the opposite side, 100 miles squared, over 2 times 150 times 225.6. And that gives you an angle of 19.7 degrees. Here we're given B is 1, C is 3, alpha is 80. What's A, what's beta, what's gamma? All right, fine. A is root of B squared plus C squared minus 2BC cos alpha. B is 1, C is 3, B is 1, C is 3, alpha is 80 degrees. So there's A, which a few keystrokes gets you 2.99301. Very close to C. So we should get a near isosceles triangle. Beta, well, for beta, we have the sides 3 here, and A, which is 2.99301 here. B is 1 here. So beta is arc cosine of 3 squared plus 2.99301 squared minus 1 squared over 2 times 3 times 2.99301. Keystroke gives you 19.21 degrees. Gamma, well, we do the same thing. The sides are A, 2.99301, B, which is 1, opposite is C, which is 3. So 1 squared plus 2.99301 squared minus 3 squared over 2 times 1 times 2.99301. Arc cosine is about 80.79 degrees, and that solves the triangle. Okay, there's in the modules, you'll see, let's look at this. There we go. I have extra credit sets. I mentioned it the other day of what I call it the pendulum, or it's the side-side angle, or the ambiguous case. And I earlier solved it by the law of sines, which works well enough. But there's also one method which you can solve by that, and which also derives the law of cosines. Here's how it goes. So we have this ambiguous case, and oops, sorry, that's how it is. Sorry. So we have angle alpha, side B, side A on the far side. We want to know what this distance C is here or here. Well, we drop a perpendicular, call this length F. Goes left or right, distance E, and C then will be D minus E or D plus E. That's in the two about solution case. C is D plus or minus E. D, well, that's easy enough from this right triangle here with hypotenuse B and angle alpha. D must be B cosine alpha. So C is B cos alpha plus or minus E. To find E, well, e squared plus f squared equals a squared. F is the opposite side of this hypotenuse beta with an angle alpha. So f equals b sine alpha. That's easy enough. So putting this together, e squared plus b squared sine squared alpha equals alpha a squared. So e squared equals a squared minus 2b minus b squared sine squared alpha. So use the square root of that. And so c is b cosine alpha plus and minus the square root of a squared minus b squared sine squared alpha. I call this the pendulum law. I'm sure it's been known. I had to rederive it for this course. It's another way to get to these, to solve the side-side angle problem. But to find the other two angles, well, first from this, we derive the law of cosines. So first we subtract c minus b cos alpha equals plus or minus this root, square both sides, expand this, c squared minus 2cb cos alpha plus b squared cos alpha equals a squared minus b squared sine alpha. Then we transpose the b squared sine squared alpha. These merge into a b squared. So c squared minus 2cb cos alpha plus b squared equals a squared. And that is the law of cosines, derived earlier today by this hour by a different method, but it's the same result. And then from this, we'll solve for cos alpha, same as before. We transpose the c squared and the b squared, divide by minus 2cb. The minus cancels these negatives and puts a negative here. So cos alpha is b squared plus c squared minus a squared over 2bc, and take an arc cosine, and we now have the law of arc cosines again. So this solves side, side, side yields angle. So from that, we have three versions of the pendulum law, three versions of the law of cosines, and no doubt you can, from the law of cosines, we can derive the pendulum law. And from the law of cosines, we have three versions of the law of arc cosines. So from that, you can solve these side angle problems, which we could also do by law of sines. And here we have the solution where there's no solutions. Here we have exactly one solution because B is 90 degrees. Here we have two solutions, which we have to work out separately and answer separately. And I do believe and here's, again, is where we have 8 problems about side angles. And some of these have no solutions, and some have one solution, and some have two solutions. Okay, I do believe we've covered the material for the day, and it's a pretty significant. Law of cosines is pretty good. I must confess I have a certain fondness for the law of arc cosines, because it always seems right that you should know the triangle by its rigid sides, but then what are the angles? So never mind that. Okay, that's this for this. All right then, questions, comments, requests. All right then, motion to adjourn. Is it seconded?
Professor, I'm sorry, I do have a question. I was trying to unmute myself. For homework of 4.2 for the extra credit number 38.
One moment.
Okay.
Problem homework set 4?
Yes.
You're way ahead.
Number 2? No, sorry, number 2. 4.2.
I'm confused. Which homework? 2 or 4?
2.
2. 2-4, not 4-.
For chapter 4, yeah, chapter 4, section 2.
No, I'm confused.
Sorry.
Which chapter is it, 2 or 4?
It's chapter 4, but for section 2, the one we did yesterday. Sorry.
Okay, right, got it.
So for the
number what?
Number 38, it requires 37 to be solved. Would that be 2 extra credit points?
37 to be solved?
Yeah.
Wait. Is it 4 to number 32?
No, number 38.
38.
Yes.
Okay, I don't think you asked for. I don't think I asked for number 38.
It's
37. I did ask for 37. I didn't ask for 37.
Yeah, you asked for 38, but it says use the illustration in problem 37 to find the height. So we have to find the distance to find the height.
Let's take a look at this. 4 to 38. Well, sometimes you have dependent problems, and that's just how it works. Just a second. For 1, for 2, sorry, 38. Oh, with the illustration right above. Sure. I suppose you may indeed have to find the distance from P to Q, or there may be other methods like Q to R or whatever.
Okay.
Good point. Yeah, interesting. Yes, that often happens in math. You have to know everything up to a point, and you know to get to the last point.
Yes, very true.
So I guess I've for extra credit assigned you to do the work for 2 problems, give the answer for 1 problem. How unfair!
Very.
Oh God. Life's unfair, and I'm part of life. Okay, more.
Okay, thank you.
No problem. Okay, well, like I said, a motion to adjourn is always in order. So is it seconded?
Seconded.
It is seconded. Okay, I'll be seeing you tomorrow.
Thanks, Professor. Bye-bye.
Thank you. Bye.
Thank you.
Yes, sir.
Thank you. Bye.
Tomorrow, area of a triangle.
Hello, Professor.
Yes, sir.
Yeah. How about the extra credit? Is it gonna be submitted the last day or the
I'm
whole
sorry.
extra credit?
You
Is
mean,
the extra credit can be
whoa,
submitted?
which extra credit? The one attached to a homework or the independent extra credits?
The independent extra credit.
Right. Okay. Yeah. By the end of the semester.
Okay. Okay. Cool. Just make sure. Thank you so much.
No problem. See you then.
All right.
Professor,
Yes.
I arrived a little later. I think I missed attendance earlier.
I got you in. Yeah. Let me take a look. Let me double check. Double check. It is mostly pro forma. It's really a ritual, but
Oh, okay.
I don't mind. Yeah, I got you down. Don't worry about it.
Thank you. Have a good day.
It's a ritual communal.